Okay, we're going to go through an example using the equations of kinematics. The example is a little bit of a longish one because we're going to have to think about a few things with a little bit of care and try to interpret what the equations are telling us. So the information that we're given is the initial velocity is positive 3,250 meters per second. The acceleration is constant, minus 10 meters per second squared. So it's basically close to 1 g worth of acceleration. And that is all at our initial time, which I'm going to take to be 0. And we're asked what is the final velocity when the craft has gone through a displacement of 215 kilometers. So the first thing I want to do is make an inventory of the 7 possible variables and make note of which things we know, which things we need to solve for, and which things are irrelevant in this particular problem. So I'll make my inventory. So there's an initial time, an initial position, a final time, a final position, an initial velocity, final velocity, and the constant acceleration. And the acceleration is constant because otherwise you can't use the equations of kinematics. All right, so things that we're given to start with: initial velocity plus 3250 meters per second. That was given. Acceleration minus 10 meters per second squared was given. I am free to pick when my clock starts, so I'm going to pick that initial time to be 0. And we're given delta x, the displacement, so that's x final minus x initial. So that has to be 215 kilometers, but I'm free to pick where I want to start measuring from. And I'm just pick x initial to be 0. All right, so we are given information on what the displacement is. If I pick x initial to be 0, that tells me that x final is plus 215 kilometers. And that's true because delta x, which is x final minus x initial, was given to be 215 kilometers. And I was able to pick x initial to be 0. All right, what else do we know? V final x is an unknown. That's what we're asked to solve for. And T final is unknown, but not asked for. Okay, so if we're looking this over and thinking about what it would be a good way to proceed, we want an equation of kinematics with the final x velocity, because that's what we're trying to solve for, so it's going to have to be in the equation. But we do not want to have t final or delta t. And that ensures that we'll have an equation with only one unknown. Okay, so that tells us that a good equation to work with is the fourth equation of kinematics, the one that does not involve time. So v final squared minus v initial squared is twice the acceleration times the displacement. Okay. So I'm going to take that equation and isolate the only unknown, which is v final x, so that's on one side all happy by itself. So it just means I move minus v initial squared x to the right hand side. Okay, and now everything on the right hand side is known. I can plug it in, and I have my one unknown that I need to solve for on the left hand side. Okay. So I'm going to resolve the square by taking a square root of both sides. So go through, do that, and do that, and now I need to be a little more careful. Because there are two possible signs of v final x that would satisfy that equation. So I have to take both possible roots, the plus and minus, into account. So it's everything that's under the radical, like so. And in a bit, we're going to go through and interpret what both of those mean. All right, let me go to a new sheet of paper and actually substitute in values. So this is going to be a long one. V final x is going to equal plus minus. I'm going to have 3250 meters per second quantity squared. I'm going to have 2, the acceleration is minus 10 meters per second squared, so I'm going to pull that minus sign out. And then the displacement in meters, 2.15 times 10 to the 5th meters. And that's all under a radical. Boop. All right. You calculate that out, you get v final x is plus or minus 2,500 meters per second. Now, I'm going to talk about what those two possible roots mean. And this is not asked in the question, but if we want to interpret the meaning of these, we're going to go ahead and solve for the time at which the craft is going to reach minus 2,500 meters per second and plus 2,500 meters per second. To do that, I'm going to use the equation for the definition of the acceleration, which can be rewritten T final minus T initial is going to be the change in velocity, V final x minus V initial x over the acceleration. And we picked T initial to be 0. So for the positive root, we'll have T final is equal, we have to be careful with our signs, that's plus 2,500 meters per second. So that's V final. I will have minus V initial. So I'll have minus 3,250 meters per second. And that's all over the acceleration, which was minus 10 meters per second squared. And that is 75 seconds in the future. When does the negative root happen? That happens at a time given by minus 2,500 meters per second minus the initial 3,250 meters per second over minus 10 meters per second squared. And that is at a time of 575 seconds into the future. So here's the story of what happens. The spacecraft is going to first pass the point of a displacement of 215 kilometers going to the right at plus 2,500 meters per second. Its velocity keeps changing, decreasing by 10 meters per second for every second of time. It will eventually come to rest for an instant, and then at time 575, it will go zooming to the left, and then it has a speed of minus 2,500 meters per second. Okay. So both of the roots have a physical meaning. They both correspond to motion. In this case, we set it up so that there was a constant acceleration applied to the spacecraft, but this sort of scenario is going to happen frequently when we have motion under the force of gravity. Things will go up, they will slow, come to rest for just an instant, and then they will fall back down. And you'll see in those sorts of problems that there's going to be a symmetry in what the velocity is. An object will first have a velocity corresponding to it going up, and then at a later time it will have precisely the same speed but be moving in the opposite direction when it crosses that same point. So be careful of catching when you take a square root that you do take into account both possible roots.